This is Euclid Book 10, proposition number 38. Here's the diagram. Okay. It says, if two medial straight lines, commensurable and square only, and containing a medial rectangle be added together, the whole is irrational, and let it be called a second bimedial straight line. Okay. For let two medial straight lines, A, B, and BC. Well, obviously, according to the diagram, we have A, B, and BC. Okay. These two lines are commensurable in square only. This line and this line are commensurable in square, but they are not commensurable in length. And they contain a medial rectangle which is added together. Now we're going to say that AC, this whole length here, is irrational. For let a rational straight line DE, this is DE right here, be set out, and let the parallelogram DF, well, this is the parallelogram DF right here. Okay, this is DF right here. And let the parallelogram DF equal to the square on AC. So in other words, if we take this line here and we make a square out of it, and all four sides of that square had the length of AC, then you'd have the square on AC. So the area in this parallelogram, this whole thing, is equal to the area in the square on AC. Okay. And yes, I want you to draw all this stuff out, and we can keep track of it. And let it be applied to DE, producing DG as its breadth. Okay, so we're applying this whole parallelogram to this line, and DG ends up being the breadth of this parallelogram. Okay. And this is by Euclid Book 1, proposition number 44. Then, since the square on AC is equal to the squares on AB and BC, okay, so we have already made the square on AC. Now we need to take AB and make a square out of it, and then we need to make BC and make a square out of it. And the area in this square and the area in this square added together will be the area of AC. This is pretty obvious. Okay. Alright, then since the square on AC is equal to the squares on AB and BC and twice the rectangle ABBC, okay, so now we're going to draw a rectangle. Two sides of that rectangle are going to be AB and two sides are going to be BC. Okay, so now in order to get the area of the square on AC, okay, in order to get the area on the square of AC, you have to first add the area of the square of AB, the area of the square on BC, and you have to take the area of ABBC. Okay, remember we made a rectangle out of AB and BC. You have to take that area, multiply it by 2, and then add it to this square and to this square. Then you get the area of AC. Okay? And this is by Euclid Book 2, proposition number 4. Let EH, okay, so now we have EH, this right here, okay, equal to the squares on AB and BC. So if we add the area of AB and the area of BC, which we've made squares out of both of these, if we add those areas together, it will make this. And we're going to apply this to DE. Okay? Therefore, the remainder at HF is equal to the twice the rectangle AB and BC. Okay. So the area inside of here is equal to the... Okay. So the area inside of this is going to be the same area as if you had made, you remember that rectangle we made AB and BC, two sides were AB and two sides were BC, and I told you to multiply that area twice? Okay. See, first you make the rectangle, then you multiply its area by 2, and you will get this. Okay. And since each of the straight lines AB and BC is medial, then the squares on AB and BC are also medial. Okay. So that means that if this line and this line are medial, then their squares are also going to be medial. Okay. But by hypothesis, twice the rectangle ABBC is also medial. Okay. So, if you form a rectangle, which we have told you to do already, two sides of which are AB, two sides are BC, twice that area is going to be medial. And EH is equal to the squares on AB and BC. We've already established that the area inside of here is equal to the sum of the area inside of this square and this square. While FH is equal to twice the rectangle AB and BC. Okay? Therefore, each of the rectangles EH and FHF is medial. So now we've established that this rectangle here is medial, and so is that. Okay. And they are applied to the rational straight line DE. Therefore, each of the straight lines DH and HG, okay, so each of the straight lines DH and HG, these two lines right here, those two lines I just mentioned are rational, and they are incommensurable in length with DE, and this is by Euclid Book 10, proposition number 22. So each of these lines is incommensurable with this one right here, at least in length. Since then, AB is incommensurable in length with BC, okay, and as AB is to BC, so is the square on AB to the rectangle. Oh boy. Guess we better illustrate this. Okay, so now we're going to form a ratio. And this here is the ratio. So as this is to this, as line AB is to line BC, so is the square on AB to the rectangle AB and BC. Alright. Therefore, the square on AB is incommensurable with the rectangle AB and BC, which is by Euclid Book 10, proposition number 11. So this is incommensurable with this. But the sum of the squares AB and BC is commensurable with the square on AB. Okay. So, if we add this square and this square together, it will be commensurable with the square on AB. And this is by Euclid Book 10, proposition number 15. And twice the rectangle ABBC is commensurable with the rectangle AB and BC. Okay. So twice of the area in this rectangle, that area there is commensurable with just AB and BC as a rectangle. Okay? So twice this rectangle is commensurable with once this rectangle type thing. Okay. This is by Euclid Book 10, proposition number 6. Therefore, the sum of the squares on AB and BC is incommensurable with twice the rectangle AB and BC. Okay. So, the sum of this square area and this square area, that sum, okay, is incommensurable with twice the area of this. So the sum of this square and this square is incommensurable with this rectangle. Or actually twice this rectangle. And this is by Euclid Book 10, proposition number 13. But EH is equal to the squares on AB and BC. Now remember, earlier in the proof we said that the area inside of here is the sum of this area and this area. Okay. And HF is equal to twice the rectangle AB and BC. So twice the area in this rectangle is the same as this area right here. Okay. Therefore, EH is incommensurable with HF. This rectangle is incommensurable with this one. So that DH is also incommensurable in length with HG. And that's by Euclid Book 6, proposition number 1, and Euclid Book 10, proposition number 11. So, this length here is incommensurable with this length. Okay. Therefore, DH and HG are rational straight lines commensurable in square only, so that DG is irrational. So these two lines are only commensurable in square, therefore this whole line right here of DG is incommensurable. Okay. But DE is rational. And the rectangle contained by an irrational and rational straight line is irrational. And that's by Euclid Book 10, proposition number 20. Alright, if DE is rational, then DF is irrational. If this line is rational, this line is not. And the side of the square equal to it is irrational. Okay? So, if we were to make a rectangle out of this line right here, okay, if we were to make a square out of that line, then the square area would be irrational. This is by Euclid Book 10, definition number 4. But AC is the side of a square equal to DF. Okay. Therefore, AC is irrational. So, the square on AC is now irrational because its length is the same as this length right here. Therefore, AC is irrational. The whole line AC is irrational. And let it be called a second bimedial straight line. So now you have the definition of a second bimedial straight line. Alright. I'm sure that's exciting, but wow. I think I'll let you ponder that for a while. I will tell you more in a future video. Stay tuned.